Good morning, my name is Ngọc and today we're going to talk about chapter 17. My part will be conduct bivariate analysis with SPSS. And these are some steps to conduct a bivariate regression analysis. So suppose the researcher wants to explain attitude toward the city of residence in terms of the duration of residence. In deriving such relationships, it is often useful to first examine the scatter diagram. So what is a scatter diagram? A scatter diagram is a plot of the value of two variables of all cases or observations, and it is useful for determining the form of the relationship between variables. We will have two variables here, which is the dependent variable attitude,
and the independent variable is the duration of residence.
And now we will jump into the SPSS to understand how to draw a scatter diagram. We will open the table 17.1 and we choose graphs and find scatter. Symbol scatter. The y-axis represents for the dependent variable, which is attitude, and the x-axis is the interdependent variable, which is duration. And now we will have a scatter plot. So, what is the most commonly used technique for fitting a straight line to a scattergram? It is the least squares procedure, and the least square procedure will determine the best fitting line by minimizing the square of the vertical distances of all points. And the best fitting line is called the regression line. And now we will jump into the second step, which is general model. We will now formulate the bivariate regression model. The bivariate regression model has this formula where the y is the dependent variable, the x is independent variable, and beta 1 is the slope and beta 0 is the intercept. And according to this model, the value of y can be perfectly predicted. Beta 0 is unknown. However, in marketing research, very few relationships are perfectly defined. So the regression procedure will add an error term to this relationship, which is EI here. EI is the error term associated with the if observation. And now we will go to the third step, which is parameters estimating. We'll have this formula. EY hat here is the estimated or predicted value of yi, and A and B are the estimators of beta 0 and beta 1. And we will have the formula for A and B, the intercept and the slope. And using the number in the data table 17.1 in SPSS, we will have the intercept and the slope and the intercept. Now let's go to the fourth step, which is standardized regression coefficient. Standardization is the process by which the raw data are transformed into a new variables that have a mean of 0 and variance of 1. And when the data are standardized, the intercept will be assumed as 0, which is beta 0 equal to 0. And the slope obtained by the regression of y on x will be equal to the slope obtained by the regression of x on y. And now let's jump into the fifth step, which is the significance testing. So the statistical significance of the linear relationship between x and y may be tested by examining the hypothesis. And we'll have the null hypothesis is H0 and the alternative hypothesis is the H1. And now let's figure out how to do the regression on SPSS. With the same data, we choose analyze, regression, and linear. And with the same dependent and independent variable, we will have these tables. Now we'll have the adjusted R square is 0.86, which is larger than 0.5, which represent the model is good enough for us to use. Now in the ANOVA table, we'll have the significance is nearly 0, which is less than 0.05, which means the model is good. Now the coefficient table will have the significance of the duration is nearly 0.2, so it is good, we will keep that variable. And the standard coefficients measure the effect of independent variable on dependent variable, which means duration will have 93.6% effect on the additive. And we'll have the standard error of B is estimated as 0.07. And according to this table, we'll have the beta 0 and beta 1, and we'll have this regression model. And you see the beta 1 is positive, which means the duration of resonance have the positive relationship to additive. We'll have the C value is 8.414, and according to the table, appendix table, we'll have the critical T value is 2.228. And in comparison, we'll have the T value, our T value, is greater than the critical T value. So we'll reject the H0. And now let's jump into the sixth step, which is strength and significance of association. The strength of association is measured by the coefficient of determination, which is R squared. And R squared varies from 0 to 1. And we'll have the formula. We'll have the total variation as Sy is equal to the sum of variation accounted by the regression line SS regression, and the variation of the error or residual SS residual. And we'll have the formula for each of the components. So we'll have a formula of R squared. Now we'll test for the significance of the coefficient of the determination. The hypotheses in these cases are like this, the null and the alternative hypothesis. And the appropriate test statistic is the X statistic, which is this formula. And the F test for testing the significance of coefficient of determination is equivalent to test the following hypothesis. And the seventh step is prediction accuracy. To estimate the accuracy of predicted value, it is useful to calculate the standard error of estimate. And this statistic is the standard deviation of the actual Y values from the predicted Y hat values. And we'll have the formula like this. And more generally, if there are K independent variables, we'll have this formula. And the researcher may want to predict the mean value of Y for all the cases with the given value of X, say X0, or predict value of Y for a single case. And in both situations, the predicted value is the same and is given by this formula. And that is the end of my part. Thank you very much for your attention.